Yeah, hello guys. So this is my second video in graph algorithms, and today I'll be teaching you how to implement BFS. BFS is basically a breadth first search in a graph. The meaning of breadth first search is quite simple. It means it searches the graph by different breadths, that is levels. You'll just understand it. For example, if there is a particular node at some particular point, then it will visit that node. Then after that it will visit all the nodes that are reachable from that node. These all nodes will be a level down. Then it will visit all the nodes that are visited by those nodes. So it will kind of like create a tree. So breadth first search is something related to a tree. You just get the idea. So I'll just implement it. So we input a graph into this function, right? Then to start a breadth first search, we need a starting vertex, because we need to start the breadth first search from a particular point. And the the thing with breadth first search is that you start from a particular vertex, and there is no guarantee as to whether you will visit all the vertices, all the nodes of the graph, because there is a probability that the graph is not connected. However, in the case of our depth first search, it's not the case. You visit all the points, right? So the next thing is basically the level. This level will basically store the level of that node. The node that we start from has level 0. Then we go to level 1. All the nodes that are reachable from that node are level 1. Then they increase as we go down. It becomes +1. And then we've got a parent vertex, a parent array. Right. So we use a queue here, and inside that queue we first of all push the starting vertex. Then we initialize the level of S as 0 and the parent of S as -1. Right. You don't need to initialize the parent of S as -1, because the level and parent arrays will initially be initialized as -1 when we are passing them, right? But still, just for the sake of clarification, I'll write this. Then we start a loop which goes on till the queue is empty, and this, then we take the top, that is the front of the queue, and we pop it, right? And then we see out this this element, right? This is the first element of the breadth first search. We pushed the first starting vertex inside the queue. We started the queue not empty, and we popped it out, right? If we leave the while loop right here, then the while loop will definitely stop after one recursion, because the queue will become empty. However, we are not going to do that. We are going to now go inside the list or the edges of that element, that is x. So we are going to find y. So we are going to find variables y such that x y is an edge with some weight w, definitely. So let's do that. To go into its edges, its corresponding edges, we will need an iterator. Yeah. And this goes on right. This goes on till gx.end, right? Now y will be equal to *it dot first, that is x to y, and w will be equal to *it dot second. Sweet. Now we will have to check if the level of y is equals to -1. This means that it has not been visited before. The level of y is equals to -1. Then we initialize with the level of y equals to 1 plus the level of its parent, and the level of its parent is x, and we write parent of y is equals to x, and we push y inside the queue. Right, that's all. Yeah, the use of w is not in here. We don't use w in this. We don't require w actually, but still. Right, so we just need this. Right, so this is BFS. Let's just call it. I'm just going to input the graph like we did last time. And we'll initialize the graph, let's say with 100. I don't know what's the problem with this. Yeah, and then yeah, I have already discussed how to input and output a graph, so you can go back to this that video. See, the graph here I'm taking as directed. I can also take it as non-directed graph, that is undirected graph, and we'll just see what's the difference. Let me take it as undirected graph. Right, so I'll just comment this so that we'll just look at the difference, and we'll just call my BFS. It goes to G comma, oh, we have to define the level and parent arrays also, so I'll just define level. The size of the level and parent arrays have to be same as the number of vertices and the number of nodes in the graph, right? Because that's quite obvious. Initialize it with -1. Yeah, now I can call it BFS G comma, let's start with vertex 1 just for the sake of it, level, and then you got parent. Yeah, I hope this should run. It is a directed graph, not an undirected graph this time. So my graph is this, the output is this 1 2 3 4 5 6. Now see what happens if I take it as an undirected graph. Maybe some vertices will repeat, I don't know, let's see. No, in this case there's no problem here. So yeah, the answer is correct. So yeah, this is BFS breadth first search. Thank you.